I think it's E.
I didn't do the notes this time, so I don't know anything that you were talking about.
How was it easy?
It's positive to most negative, so the glass ice is usually electronic, so it's positive plus W.
Everyone said
And then it goes proton, one proton, D, C.
I had a bunch of quizzes turned in. Remember when he said that they were
Well, I typed it back.
You what?
I loosened that.
I'm about to say you did not type.
I had to play all the
He tightened that foot. I hold hard.
I just put miscommunication.
Lord? No, I went to I went to a elementary school to help them because they I spit on y'all.
They can't even afford to do that.
No, we do it every year. Me and you and the row.
Am I stupid?
You black nigger.
So I will check it out and see which one's the best. Or if there are multiples that are
How do you make this
recommended.
harder? Am I stupid?
Very much.
Yeah, the metal thing has to go
I got
to
some.
the.
Yeah, that's what I'm trying to do.
Do I have to show up?
Yeah.
Yeah, I got mine. I don't think we have the extras. But next year we will. Because
She can feed herself.
as in, so as in I2 or you guys get the priority. Because that's going to be the year that you're testing with the IB stuff.
How do you put it up there?
Unfortunately, we just don't have enough to go around. They're kind of pricey.
I don't use my fingers. It's so annoying.
Cute.
That's what I broke my finger. This nigga tightens it to the max.
Notes.
It's only 6
I like
months. Would you believe me if I told you my dog in my notes?
I love it.
My dog in my notes.
Thank you.
Mr. Maynard, my dog in my notes.
Your dog ate your notes?
He was like, he wanted to learn about physics.
Ah, yes.
You know he said you are what you eat?
He
So technically your dog is a physicist.
he wanted to well, he didn't eat a physicist. He ate physics notes.
So he became physics.
But he internalized the awesomeness.
Wait, so that's what I gotta do to understand this class?
I gotta eat. Maybe.
Well, I would not suggest eating paper and ink. I don't think that
Well,
would
what
do well
about,
with
like,
your body.
Eat
but-
paper.
If you write it on maybe some rice paper.
Maybe
with,
maybe
like,
she
paper.
still does. Like she cares about
Maybe with some like
Edible
some
pens,
edible markers.
Maybe it's edible.
with ink
frosting,
or fruit juice
frosting.
frosting.
That's cooked.
You can do that
I
too.
can
Yeah.
bake. Okay, if it doesn't work, it's all y'all's fault.
I am not saying that eating notes will make you more knowledgeable in physics. But, alright, I checked all notes. Did I miss anybody for notes? Going once, going twice. Our dash for today says, that's how we roll.
Can I use two again?
I gotta go with one. Ooh, what'd you say?
7 days without a hike makes 1 week.
Oh, 7 days makes 1 week.
And if you don't hike often, you'll get a week in your
It's
hiking
easier if you do
skills.
it upside down.
That was good.
Just like my Spanish.
Ah.
After high school, I never
makes
used it, so
one.
I lost it all.
Thank you. We have Google Translate.
That wasn't
No, I'm
on
actually studying
purpose.
revolution of the class.
Alright,
Can you do it?
who's the Jordan? Do you want to take the test today or?
This is my last
another
year.
day?
I gave him my laptop.
Today? Okay, cool. So let me get that started for you.
No, I'm probably
Alright, last chance to answer our Beller question. Well, I switch gears here.
I think you're just weak.
So,
I feel
so
lightheaded.
wait, just so I'm like, I know for sure, when something's missing 3 electrons,
This is my good
that
one.
means that it
This is my
has more
good.
protons than electrons. So positive is
Now
plus
this
3.
one,
right?
Uh-huh. Yeah, I took notes.
Wait, who's talking about protons and electrons? What chemistry is happening?
You didn't take chemistry, what?
What did you ask him?
When something loses 3 electrons, that means the charge is +3 because that's 3 more
Yeah,
protons.
comes more positive because it loses a negative charge.
Yo.
Oh, chemistry was so fun. I miss it.
You know it was.
Wow, look at these spirit colors.
Probably was.
I got a spirit color from Oakland.
Oh, shit, my bad.
I'm not answering it. It's probably gonna be some one of my out of the mic, bro.
Yeah. Yeah.
Alright, Gina, so you can click on that same link
Yeah,
that
this
we
is my
posted to Teams.
How is Ham?
I hate you.
I use more of my fingers instead of like the whole rip it like this.
Martin, did you sign up for something?
Four.
Okay, thanks.
So as we get started, we are going towards the season of choosing classes for next year. We won't necessarily talk about things a whole lot today, but sometime in the next week or two, I will be discussing your possible future courses if you wish to continue with your physics education. However, I do know that physics is not for everybody, and if this is your one and only physics class, it has been a pleasure to have you.
It's been a pleasure, man.
Nice knowing you. I will come visit.
Yes, absolutely.
Can I be
Yes.
your
Come
TA?
visit me. I am always in the lookout for good TAs. Yes.
Do I get to like grade
As
people?
long as you like sorting Legos, and I mean, you can come to Busch Gardens with us too.
I hate Legos.
Sounds like a blast.
I hate Legos.
You hate Legos? I'm sorry.
I don't like
I stepped on them when I was younger, and I've
Well,
been traumatized.
You shouldn't be barefoot in my class regardless. So that
Well,
shouldn't
like,
be an
you
issue.
understand, like,
Can't become TAs after this, bro.
what happens happens.
What?
My teacher still let us take our shoes off.
They are.
We never question the journey.
Well,
I could be a TA though.
me.
Yeah, we'll be your TA.
No, if
I'm sure that you'll have friends that
I'm a
will
TA,
continue.
I'm a TA on the trip, and I like sorting things.
Besides, all of your AP junior friends for next year will be in physics as well. So, and they'll get to go if they make the grades.
All of them.
Do you still give curves to the IB test?
Huh?
You still curve the IB?
Oh yeah.
Same curve?
It's slightly different
That was like.
because the grading mark bands are different for AP versus IB.
Is it like a better
All of
curve, or?
I think it's slightly better. Yeah.
Hold up. Wait a
Okay,
I got a 9.
I'm not.
think-
I'm not an IB.
Yeah.
I don't know if I want to do IB visits. Can I take it?
We'll talk about all that not today because we're already short on time. We gotta get started.
Spanish.
Oh yeah, we got
But
short on.
maybe on Friday, we'll see. We'll see.
I got to take chemistry.
All right.
Wait, Mr. Maynard.
What?
You like it?
Wait, Mr.
So
Maynard.
you're taking
So typically you have to be a senior to be a TA. There are extenuating circumstances where juniors can be TAs. Actually, I had one year that I had a sophomore as a TA, but she actually came like halfway through the year and they needed a spot to put her.
I have a question, like,
Yeah.
if they just threw me in the TA class, like, this year, can I be a TA like next year?
So if you're a TA this year, are you? Okay. I don't know. That would be a guidance question, like with your counselor. So, yeah. I don't know all of the ins and outs.
Can I have 5 gym classes as a senior?
5 gym classes?
Yeah.
That'd be kind of ridiculous.
Yeah, no, exactly.
You're an IB student.
Or can I be like a gym teacher's TA and I can just go hoop?
Now, are you AP track or IB?
IB.
Then it's impossible to have 5
Yeah, I'm
gyms.
not.
Hey, you have to jump team next year.
Because
Huh?
you only have like
Guess
one
what?
free
If you go to
class to
7th grade
choose
schedule,
as
you're
an
not
IB
getting
student.
elected, bud.
Really? Wait, next year, so I only have
You
one.
have to take
go up
prep
there
next year
and stand by.
anyway.
Yeah.
You're done.
So as an IB junior and a senior, you only have one true elective.
I want to drop
But am I leaving it?
That sucks for y'all.
That is assuming that we are still allowed to keep our 8 classes.
That's what I told me not to
scheduled.
take the IB
That
track.
sucks for y'all. I still
They were
get. I
like,
still
you know
get
what?
two.
Whole nother ball.
I told my
of wax.
Still
senior
get
friend,
two.
he was like,
You're two
I'm doing IB.
I have three.
No, I'm talking
Good luck.
about
Okay.
No, but the fact that you
Nisa,
are
where
able
did you
to
go?
don't take these classes and then they're
From
still
Iggy?
failing. Like, what's happening?
Alright.
I'm
The
supposed to.
required
busy.
classes.
Like 3.
No.
So I can't have like 2 gym classes?
One.
Alright, here we go.
My brother's took
I'm
regular
taking
I want to go
classes.
hoop with Coach Elliott.
Oh, I'll take 4.
He failed, bro. Like, didn't graduate.
Alrighty, so we got C's, A's, E's, and B and D. Wow. I've never seen all 5 answers being put forth here.
Somebody has to be wrong.
Here we go.
So,
So,
a lot of points.
as we talk about electric charge, a lot of this you may already know from past science courses, like there's 2 types of charge, and where do those charges come from? Positive charges come from protons, and the negative charges come from
Electrons.
electrons. Yes. And what's the deal with neutrons?
They're neutral.
They are in between.
The prefix.
Well, see, what happened was,
So the light.
so there's a fine line between being neutral and having no charge.
No charge.
Okay, so neutral means having equal amounts of charge. Equal amounts, so like a book, if this were electrically neutral, and of course this contains trillions of atoms, it's gonna have equal numbers of protons and electrons so that its net charge is 0. Okay, but we call this neutral because it has equal amounts of charge. A neutron actually has no charge whatsoever. It doesn't have any positives and it doesn't have any negatives.
Why do we have
So
It drops all charges.
it is no charge.
Why can't we just call it no charge?
Particles.
Why can't it be so different? Why can't it just be like no charge?
It makes sense.
Is there an object
Because
that
aren't the protons that make sense?
Say what?
is there like an object that's
Jordan.
An object that has no charge. The only things would be particles.
What?
So in normal matter, the protons will have the positive charge, the electrons have the negative charge. Whatever's plugged into that isn't charging, but now it is. And the red light was on, so it's in test mode.
There's a red light?
Yeah. If you press the test button, the little reset button pops out, the red light comes on.
Oh,
Yeah, I've been wondering
And
what
that's a test saying, hey, does this have electricity or not? If the red light is on, then yes.
Yeah.
But anything that's plugged into it is temporarily shut off because the current isn't flowing, because it's in test mode. You have to reset it in order for the current to flow again.
Oh, I thought that was just a
Our
little
last
fun.
game today, y'all. It's the last game.
I like dancing too. Dancing is good for the soul. Salsa dancing.
Yes, I got all of it.
Yeah.
Can I get extra credit if I say
No. I'm sorry. No.
Okay,
Okay, guys, we are losing time. I want to give you at least, 10 minutes or so to work on your pods, but right now we're not looking too loud, so let's just stay focused, shall we?
Why does the neutron never go to prison?
Why?
Because it drops
Okay,
all charges.
so
Mm.
the charge of a proton and an electron, if we look it up, and of course it's on our equation sheets, we can look that up. It is actually called the elementary charge because the charge of an electron or a proton is 1.6 times 10 to the negative 19 coulombs. Coulombs is our unit of charge. 1 coulomb is a lot of charge. A lightning bolt can hold anywhere between 5 and 25 coulombs of charge. So 1 coulomb is a big amount of charge. So naturally, this is a very, very, very small number for the charge of 1 measly electron or proton. Naturally, if it's an electron, that's going to be a negative 1.6. If it's a proton, it's going to be a charge of positive 1.6. So that would make sense being if we have a neutral object and it has equal amounts of protons and electrons, the total charge would equal to 0 because they have the same equal but opposite charge, and there we go. Now, something important here, charge is said to be quantized. Quantized is a fancy word for saying that these things only come in smallest discrete little packets, like I cannot have anything smaller than the charge of an electron. It is impossible. Okay, like attendance, like people are quantized. If I were to take attendance, if I count the number of people in here, I would say there's like 19 people in here. Okay, it would be foolish for me to say 19.5 people or 18.8 people, because how can you have a partial person? Okay, that is impossible. People are quantized. Even if you go to war or you get into a car accident and you lose a limb, okay, you may not feel like a whole person, but attendance-wise, you are counted as a whole person. So, people are quantized, charge is also quantized. So, that means that I cannot have 1.5 times 10 to the negative 19 coulombs. That is impossible. I can also not have 1.7 times 10 to the negative 19 coulombs, because that would be 1 plus a fraction of an electron, which is impossible. However, any larger amounts will be multiples of the elementary charge itself. So like the charge of 2 electrons would be exactly twice this, 3.2 times 10 to the negative 19. We can have a charge of 3 electrons, which would be 4.8 times 10 to the negative 19. But I will never have a 4.0 times 10 to the negative 19. It is impossible, because they have to be discrete set amounts. So charge is quantized. There we go. So let's move on to answer our question here. We are ranking in order. Gotta love those ranking questions. We've seen those a lot recently. From most positive to most negative of the 5 systems. So here we go. So in A, B, C, D, and E, A says that we just have 1 proton. That means that we have a charge of positive 1e. E stands for the elementary charge. Okay. Excuse me. Somebody scamming is calling me. Now the electron, if there's only 1 electron, then that's going to be 1e in the negative. Okay. C says, so remember that equal numbers of protons and electrons, basically they cancel out. So we're only concerned about what's the difference of the 2. And the difference says that we've got 2 electrons, so that's going to be a charge of 2 negative on C. D, even if we have 1,000,000 protons and 1,000,000 electrons, the net charge is still 0. That is truly neutral. So D is 0. And then, of course, E, a glass ball missing 3 electrons. That means that it has technically 3 more protons than electrons. So that's going to have a 3 plus for our positive here. So as we rank them from most positive to most negative, we'll see the positive 3 is first, so that's going to be E. And then the positive 1, A. And then the 0. So D, and then the negative 1, B, and then the negative 2, C. Most positive to most negative, that would be E, is the correct answer for our Delaware question.
Congratulations,
Yes.
coach.
All right,
I got a question
let's
right.
record our answers, and here we go. All right,
You're lucky we don't have
we got
Zay
some
here.
good changes here.
Yeah, y'all
Let's see,
we got
E's,
Zay.
we got
Hey.
atoms.
he was the smartest one.
He's the smartest one.
We've got
Yeah,
spectrum. We've got Terra.
Didn't you take
Heard change his answer twice, so that's okay. Okay, means 1. And that's it. All right, good, good, good.
You just doing that?
So, notice that we are now in the D section. We actually studied the D1 section before when we talked about gravity and orbits. So those equations might be familiar, but we're on the D page now, talking about D2. And the only real equation that we have for you today is our electric force equation, which looks a lot like our force of gravity equation between 2 masses. Recall, the top equation in D1, the force of gravity is G m1 m2 over r squared. We talked about that in great detail. We learned that it is an inverse square law. The force is inversely proportional to the square of our distance between the 2 masses. But this is very similar to our new electric force equation that we see in D2, where we still have a force, although this is going to be the force due to gravity. This is the electric force. I'm adding those subscripts, but they're not actually on your equation sheet, but they are in separate boxes, so it's pretty easy to tell. And then we start off with a constant K, which is also equal to another constant, which the book talks about. But then we've got our two charges, Q1, Q2, over R squared. Look at that. The electric charge and the force of gravity, the electric force and the force of gravity are the same format. Both of them are inverse square laws, so they'll work exactly the same way. However, now that we've got two kinds of charges as opposed to only one kind of mass that we had before, now we also have two kinds of forces as opposed to only one force that we had before. We learned that the only force acting between the two masses is an attractive force of gravity. Looks good. But then the electric force, it could be attractive or repulsive. Get away from me. And of course, you guys know the like charges do what? Like charges repel and opposite charges attract. There we go. So the signs of the charges tell us what kind of force it is, but that really does no bearing on how big the force is. How big it is, it really depends on how big the charges are, either plus or minus, it doesn't matter. And of course, the distance between them. All right, good. Let's jump into our next challenge question. Here we go.
I can look and solve these. These are looking easy.
Where's my mouse?
So this is the chemistry score. Now this makes sense. Now what other stuff has nothing to do with
There you go. All right, challenge question live on the screen. Here we go. Time is of the essence.
Okay. The charges.
Essence.
D.
Oh, geez.
There's no E.
Exactly. They tricked them before they even look at the
I put D.
Oh, yeah, you trust me? You got D.
I was trusting you.
Why, bro? How would you do that?
It's B.
Why the hell would you do that?
Wait. So it's the 2 points. So that's 4.
It's probably D. Probably D. Would it just stay the same?
No, it's not A.
Would it just stay the same?
I think it's B.
It's either B or D. It either stays the same or just quadruples.
Well, it's distance, so it's no.
I don't think so 2 points and
So there's nothing up there. It's just
No, like E. It's inversely related. So it's double than
Buzz. I'm gonna call it done. 3, 2, 1. Done. Here we go. All right. So the magnitude of the force of attraction between 2 point charges is F. But we know because they have an attractive force, what's true about the nature of the charges? They're opposite charges. Yeah, they're opposite charges. So if the magnitude, again, just the size of each point charge is doubled, and the distance between the charges is doubled, what is the new magnitude of the attraction force here? So let's take a look here. So if the Q is doubled, so if one Q is doubled, there's an extra factor of 2. If both of the Q's are doubled, so then there's 2 2's on the top. And then if the distance is doubled, then that has to be doubled as well. But whatever factor the R is also has to be squared. 4 over 4 cancels out. It's the same force. Nothing changes. B is the correct answer.
I missed this one.
Yes.
I was right about the 2 being square. I was right about that.
Looks like Bella, Spice Girls, taking first place. Good job. Followed by, let's see, Aberrain Youth Maniacs taking second place.
When I first
Very good. And then we've got, Aperba didn't put in the asterisk later. Sean, so Team Sarah.
When I first read that,
Yes.
I was looking like, okay, so
So now,
Mr. Manor.
yes.
Which never mind. I looked at the wrong thing.
Cool. Now, some possible problems that you might
I
see
accidentally looked at this.
may look like this,
And the R
where
doesn't have
we've
a
got
square.
a combination of not just
Wait,
two
where is
charges, but maybe a system
This
of
one is the
three
one you're
charges.
supposed to use.
Okay, where let's say we have a 1 coulomb charge here and a -2 coulomb charge here and a +3 coulomb charge here. Okay, and maybe we're asked to find what is the net charge, what is the net force acting on a particular charge, and based on what we're talking about, it may be different. Like if we focus on this guy, so if the net force, what's the direction of the net force acting on this one? So I would have to calculate, notice that if I were to erase my changes here, so notice that the force is only, our force equation only contains two charges. So I can only do the force between two charges at a time. So if I want to find what is my net force acting on my 3 charge, then I have to find what's the force between these two, and what's the force between these two, and add them together. But as we're going to see, based on their direction, we may have to add them in 2D, which we've done before. Okay, so let's just map it out. Let's see how we would approach it. Okay, because I'm not going to go through a full example. So if we're looking at this charge, so my 1 and 3, they are both positive, which means that this force is going to be pointing where?
Away from each other.
Away from each other. So if this is my system that I'm talking about, which direction is the force pointing on the 3? Up. Good. So this is going to be the force between 1 and 3, and that's going to be pointing up. Now, naturally, it's going to be the same equal but opposite force acting on the 1, right? Because Newton's third law, forces have to come in pairs. So if the 1 pushes the 3 away with that amount of force, the 3 pushes the 1 away with the opposite way with the same amount of force. Yeah. Okay. Now, let's take a look at this force. Notice that these are opposite charges, so this is going to be an attractive force, right? So where is it going to point? It's going to point
That way.
That way.
Yo, buddy, you're going like.
So this is going to be the force of 1 on 2. So as I calculate, I'm going to have to calculate originally the force of 1 on 3 using this equation with 1 and 3. And that would be that force. Then I have to do it again for, I'm sorry, I said 1 and 2. That should be 3 and 2. Yeah, my bad. So this is our force between the 3 and 2 charges. So I would have to calculate it with the 3 and 2 here. And its own R, which would be different. And then, of course, I would have to add them in 2D if we need to go that route. Good, good, good. All right. Well, let's take a look at a not so complicated problem, but still definitely one worth of thinking about. Next challenge question, here we go. Yo.
I think I would read that. You said what?
This is C.
What's the math?
Unknown.
I think it's like low key. I don't think it's because you
The negative
Sorry.
because if you think about it, right? 4 to 1 person, that would be at that point. I thought I knew what I was talking about, and I realized I have no idea what I was talking about. It's complicated. We're not sure.
I mean, if you put nothing's gonna
Oh, well. Doesn't matter. It's not my go.
What are you doing to your hair?
Part of me, just checking
I
things.
took one of the first ones right, the bottom right. Over here now. I did a, yeah, I've been growing for 2 years. I don't know.
It doesn't really make much sense either way. I got locked in here.
Not my curly hair either. Keep that in
And then another.
Let's see. Oh, the then we started to change the B's.
What'd you pick?
He didn't literally give me things. He had
Alright.
scissors
Last call, 5,
today in class. He was
4, 3, 2, 1, done.
Do you lay on your sides?
Alright, and locked in. Let's see here. Alright, so let's test it out. Okay. So as we do testing, it is common to use a small positive test charge as we test things out. It doesn't have to be positive, but that's typically what we do. We will use that same approach in the future as well. So let's say that we go right in the middle, which would actually be right here. Okay. So if we have a small positive test charge here, let's take a look. Now, the question is asking, where can we place an unknown point charge and have it remain at rest? So technically that would mean that the forces acting on the charge from both of them would have to cancel out. Okay, so net force is 0, the forces have to cancel. So let's take a look at these forces. So if this were equidistant here, keep in mind this is our force of the Q1, Q2 over R squared. So if they are equidistant here, the force R, that R is going to be equal to that R, if it's right in the middle at the 0.5 spot or whatever. So assuming this is just a small charge Q, which we don't know, but it doesn't matter. So this force, so because they are like charges, it's going to want to repel it, right? So that's going to be the force from 4, pushing it away. The force from 2, this is also a positive charge, so it would also repel it from here, pushing it this way, but the 2 is not as big as the 4 is. So with less charge, we've got less force. So here, we would have an unbalanced forces here, okay? So where should we slide it to try to fix the problem, okay? So if we slide it towards the bigger charge, that means that our F4 is actually going to get bigger because the R is going to decrease, and since the R is on the bottom, as the R decreases, as this gets closer to the 4, that force is just going to get bigger. But we don't want the force to get bigger. We want it to get smaller. So I could move it that way, but that wouldn't go towards equilibrium. We would actually have to shift it this way, okay? So as we shift it more into the C region here, okay, like the closer I am to 2, the greater the F2 becomes, and the smaller the F4 becomes. So that spot would fit, or would be in the C region. If we actually had numbers, we could calculate exactly the position that it would be. But that would be a completely different problem. Okay, but C is the correct answer for this problem.
What you put?
Yes. Oh, sorry, Henry. That's
To
good.
be honest, I kind of think
Alright,
about it
so
in
let's
terms
see.
of weight.
Turn some point. Alright, so Quantum taking first place. Bradley, did he change his answer? No, he did not. Spectrum taking second. And we got Adam taking that third place blind. Very good. Now,
Right, which is what I do.
jump off question. Same situation, but I'm changing something. Okay, so here's our next challenge question that you can answer. Where would this magical spot lie if instead the 2 were negative?
Farther
In which region would a point not have any force?
B.
Answer on the thing.
Oh,
This is your next challenge question.
Okay.
That 2 now becomes a negative.
Jordan, I think it'd be.
Which region would you have 0 net force on a test charge? You really don't know. You really don't.
Wait.
I changed the 2 to negative, yes. But we're still positive. Yeah? We're still positive. This one together.
No, yeah, right. D.
Well, I changed it really quickly, so I hope it's right.
Why'd you change your answer?
Because if it's
I don't know, because he said something.
no, because if it's farther to the right. No, yeah, right. It makes sense. Because it's gonna get a track
Well,
to the left.
that's the point of the question. Where would it be when the forces are balanced? Now,
Okay.
That's not what's happening here.
Why did tell me we're
It's gonna be D line.
Yeah, you're right.
It's positive, it's getting priced that way. The positive 4 plus 4 down. They're somewhere in that region.
So they're both going that way.
No, because if it's positive, it's gonna get strike.
Yeah, Martin, you're right.
It's negative. It's gonna have a positive charge.
If he's wrong, then I'm right.
So,
It's a negative charge.
Because the 4 is getting repelled.
here,
Cut it off. I can get it.
if you put
no
it
A,
right
so
here,
well done. 3.
since this is going to be a negative,
1.
and this is a positive charge, it would spin towards it. But since this is a positive, you should
Okay,
repel it, so it's
let's take a
spinning
look
this
again.
way.
So,
that means you have
again,
equal
let's
forces.
start at our halfway point, because the R is the same in both cases. That's an easy way to start. So again, the halfway is going to be right here. So, let's take a look at our forces. We still have a repulsion force from the 4. So that's our F4. But now we've got an attractive force between this and our 2. So the force from the 2 is going to be pointing to the right as well. There's no possible way that that could be balanced, because they're pointing in the same direction. We have to get it to where they're pointing opposite directions. So that means that we need to get out of the middle. It's either going to be on that end or on this end. Okay, let's try this end first. So now we're here in D. Let's see what happens. So we still have a repulsive force from the 4, but it's now smaller.
Yeah.
Because it's more away, okay? We've got an attractive force over here. That's going to be pointing this way. Oh. Okay. So there could be a spot in D where maybe they could fit. Let's take a look at A. Okay. If we go past here, so
One person play.
again, we have a repulsive force, so our F4 points left, but we're super close to this big one, so that force is going to be big, okay? We've got a force of attraction
No, because
between the
the
2,
F4 view.
so it's going to point that way, but it's really, really, really far away from 2. So that's going to be not really close to canceling out either. D is the correct answer.
I told you. I told you.
Yes.
Thought about it.
Yes.
I realized, I was like, wait. I'm at no.
Good
It
job,
has to
guys.
go right.
Let's see who said D first.
Yeah,
Looks
close enough.
like Sean
How was it
Sierra
before
taking
elementary
first
school?
place.
It was fun.
Good job.
Although I worked
Followed
most of the
by,
time.
Let's see, Bradley with that change.
I worked most of the time.
Spectrum
What do you
taking
mean you
second.
worked?
Wait, no,
Like,
they
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 put me to
rechanged
work.
their answer.
Oh, they
Doing
changed
what?
it again? Which one?
Nope, I didn't say
Cleaning
that.
what?
No,
I said the answer.
no, they didn't.
No, I was thinking about going, you know.
Yeah.
You should have gone.
changed it
You get
to
food.
D. Oh, I thought
Is
it
it
was
though?
B.
Eh.
I thought she was saying she changed it. It was B, and then you changed it
I just didn't
to
want
D.
to
So
school, you
you
know.
guys are good. Yeah. And then Jordan, let's see. So you had the B up there initially. You said D, but it didn't come with an asterisk. Oh, no, okay. Alright, so you guys still get third place points. Up and Adams taking that.
If you go a bit to the left.
Okay, good. Fine. Just a couple more things. Let's go back to the concept of charging. Okay. So there was in your reading talk of an electroscope. I happen to have one here in class. So here's an electroscope. We have a ball, a rod, the leaves, which are metal, so it's all conductive. This is an insulator, so if there's a charge placed on this piece of metal, it's going to go all throughout this metal, but not in the casing itself. Okay, so right now you can see the leaves are hanging straight down because this is neutral. It's got equal amounts of positives and negatives, so there's no repulsive force here. If I were to put a charge on here, well, let's see. I'm going to take my magic charged ruler here, and I'm going to will the charge onto it. Let's see if it works. All right. If it works, you should see these leaves go apart. No, I don't think it worked. What do I need to do to the ruler?
Static friction.
Static electricity is not a verb.
Rub it against.
Rub it! With what?
Your hands.
The claw.
Your shirt?
Ah! I happen to have a woolen cloth here.
Oh, that's like, that's really good.
Yes. Wool keeps you warm in the winter.
Cotton.
Like a nice scarf. Although it could be itchy. But my long coat is wool, so that's why I wear it when it's really, really cold out. All right, so friction is responsible for stripping off charges. Which charges get stripped off? Are they the protons that move around or the electrons? Electrons. Why?
Because they're in the outer end.
So protons are in the nucleus. It is very difficult, albeit